All right, so here we are going to do a quick review of interest, and then we're going to make a cute spreadsheet. So the formulas we went over the other day, we've got interest, simple interest is whatever your principal or balance is, times your interest rate, times the amount of time that goes by. PRT. We extended that a little bit to talk about compound interest. So again, this one is simple. If I want to do compound, interest, then there we talk about a future value, because compound interest is where your interest collects interest. So the future value is equal to the present value. And I'm going to give the second version I gave the other day. It's 1 plus, I like to use R as an APR. What's APR stand for? Do you remember?
Annual percentage rate.
Annual percentage rate. So then I have to divide by the number of times I collect interest each month, each year. It could be monthly, so it could be 12. And then the power is the number of times you collect interest a year times the number of years. So we'll use that right now. So let's suppose we take a principal of $1,000 and interest rate of, let's say, 5%. And we collect interest every month. And we're going to let this happen for, what, 5 years, 10 years? We think 7 years. 7 years. T.
Yeah, from the small bucket.
7 years. You got a treat?
No,
Calculator. Cool.
Actually, she borrowed mine in geography.
So for this future value, color.
Wait, did you want P as 100 or 1,000?
I wanted that as 1,000, so I missed a 0. Thank you.
Okay, so I put down 1,000.
That's what I meant. So my future value is going to be $1,000 times the 1 represents 100% of what I'm starting with. Okay. And then we add on our periodic interest. Now that I have to change to a decimal. What's 5% as a decimal?
0.05.
0.05. Beautiful. And we're going to cut that into 12 pieces. But although I'm going for 6 years, I get to collect interest 12 times a year.
7 years.
7 years. Ah, right. 6 in my head. 7 years. And so then we whip out our calculator and try and come up with that. So everybody whip out a calculator.
So that equals 100 or 1,000?
Ah!
1,000.
1,000. Oh my gosh.
You're fat.
And I thought I got a lot of sleep last night. I'm
It's
slipping.
too much sleep.
Too much sleep, yeah. All right, so I'm going to whip out my Google calculator. If I can type this in a spreadsheet. Times parentheses.
1,004.166.
I have an error.
An error, uh-oh. 0.05 divided by 12, close parentheses. And it depends on the kind of calculator how we type this in. Raised to the power, parentheses, 7 times 12. So again, the whole power is 7 times 12. It's got to be in parentheses. If we just put one of them, if we don't put parentheses, then it only raises the first number to the power. So I'm getting $1,418.04. Did anyone else get that?
Hold on, let me see.
All
Off
right.
air.
Let's
I don't know what
ask
I'm doing.
the Google calculator. So the other Google calculator is where I just go here and type it. 1,000 times parentheses 1 plus 0.05 over 12, close parentheses, raised to the power of parentheses, 7 times 12. Okay, give me a calculator, let me see. Oh, you have the same kind of calculator, don't you? Is it close?
No, it's
Similar? Okay, let's hear it. All right, so you have, you have parentheses, so I think we can do it. So 1,000 times parentheses 1 plus 0.05 over 12, close parentheses, raised to the power of parentheses, 12 times 7, close parentheses. There you go. All right.
1,
And lock.
4, 1, 8, 3.
Did yours do
Correct.
parentheses? Oh, you rock. You got it. All right. Right. Phone calculator there.
Yeah,
Parentheses, you have
except that
parentheses.
doesn't have
But it
any
doesn't have an
reason.
exponent.
So, no, it doesn't. What if you turn it sideways?
Here's the
Turn it
Exponential.
sideways?
Yeah.
Oh, there it is. Right there.
First of
Oh,
It
yeah, you got it.
is.
You got it. All right. Yeah. And you got
Ha-ha.
your calc.
Let me see.
That should work. All right. And I could do the same thing with Google's buttons here. So this looks a lot like the calculator on my phone. So I could type my 1,000 times parentheses. Now, some calculators don't have parentheses, which means you have to use a different order of operations. Is that what you have to do? Yeah. So you have to do the parentheses first, right? Then the power, then the multiplying the outside, yeah. So if your calculator doesn't use parentheses, then you have to insert the order of operations. So I'll do it two different ways. 1 plus
Right there.
0.05 divided by 12, close parentheses, to the power. And now here, it puts parentheses there for me by raising it up a little bit. And I should be able to just go 12 times, ooh, no, I should have parentheses. Back up. Raised to the power of parentheses, aha. So it takes time getting used to one's calculator. And there's the answer. Now, if my calculator doesn't follow the order of operations, then I have to force it. So the first thing to do in here would be the division, 0.05 divided by 12. So on some older calculators, I would have to take my 5%, divide it by 12, then add 1 to that. Oops.
That's what I was doing.
Equals. Then I have to raise that. Where's raise? Raise that to the power 12. Then I have to raise that to the power 7. And then I can finally multiply by 1,000. And there's the answer. So the question is, does your calculator follow the order of operations, allowing you to use parentheses and powers, or can it only do one step at a time? It depends on the calculator. So we have to learn to be masters of our own calculator. Often in a classroom, you'll have classroom sets of calculators, or maybe you'll have Chromebooks, and you can direct all the students to the particular calculator. And that makes life easier for all using the same calculator. But here in college, we let everyone use whatever they want, and things are more exciting. All right, so that is compound interest. So we're going to take that one step farther. We're going to experiment with compound interest and see what happens. And a spreadsheet might be helpful to do this if we have an old-fashioned calculator. What I want to do is I wonder, so let's see, it took us 7 years to make, what, $400 and something that we had there? Okay. What would it take me to double my money? How long? So I wonder how long to double my money. Oops, wrong order. Switch.
12.5 years.
You think it's 12.5 years?
Just guessing, but yeah.
That's guessing? Okay. So again, what am I working with? Well, that means I want my future value to be 2,000. Why I keep missing that zero? It's going to happen all day currently. So on the other side, I have my 1,000, right? That's fixed. I'm going to fix the interest rate. Oops, come on, well, fix the interest rate at 5%. I'm going to compound every month. So the variable here is I don't know what the time is t. It's just hanging out there. Well, one way to solve it is just guess and check. Greg said 12 point, what? 5?
12.5 years.
12.5 years.
Well,
So we,
if you look at the 1,400, then you double that, but then you figure you're compounding, so it's a little off, so 14 years seems reasonable.
that's an excellent guess. So we'll just try it. So we'll go, now the spreadsheet might be a nicer place to do that because it recorded the formula and I can just go replace the 7 with 12.5. Almost, not quite long enough, but close. Now, do you remember some tips I told you about spreadsheets before? I typed all of those numbers in there. If I'm going to experiment, it'd be better if I have a place for my experimental numbers and a place for the answers. So I'm going to redo that formula a little bit. So what I'm going to do is I'm going to put a place in here for the balance. I'm going to put a place in here for the rate. What else do we put in here? Time we can put in here. And then compounding period. Oops. So let's say we're starting with $1,000. Get that right?
Nope.
No, there we go. Rate, on a spreadsheet, I can just type 5% and it'll treat it correctly. Alternative, if I type 0.05 and hit enter, oh gosh, it put the percentage there for me, that's bad. So fix that. Format, number 0.05. The alternative is if you type it as a decimal, then convert it to a percentage, and it'll type it as 5%. I have some extra decimals I can get rid of. Time, number of years, we started with 7. Compounding period was 12 periods per month. And so down here, I could make what that?
12
Per year, yeah, 12 per year, sorry. So down here, I could make a place for the future value. And I can just type in my formula. Now this time I'm just going to point and click on stuff. Take your balance, multiply by parentheses. 1 plus your interest rate, divided by, click on your compounding period, close parentheses, exponent goes next.
No, parentheses.
Parentheses, yes, parentheses, because it's a multiplication. And I take my compounding period times the number of years. I guess I should call that column years, would be better. And so there's the number we came up with before. Now the cool thing is I can just go change that number and it'll recompute it for me. Okay, that wasn't enough, 13. Ooh, closer, 13.5. Ooh, closer, 14. 14's a little bit over, right? So then I could scale it down. I could do something like 14 and 11 months, right? 13. Oh, 13, sorry. 13 and 11 out of 12, so 11 months. Real close, 11 months is still a little too long, so I could try 10 months. So we can kind of play around. That's a little, so somewhere between 10 and 11, 13 years and 10 and 11 months, it's going to double. So during that 10th month. Now, if my bank only gives me interest every month, I got to take it to the 11th month, right? There's not much choice. Now, question. 13.9 works best. So that's how long it took to double $1,000. What if I started with $2,000? How long do you think it's going to take to double that?
Double amount.
Double that amount of time?
26 months.
Okay, let's try it. So I'm just going to redo my formula. Equals balance. I didn't have to redo the formula. I just wanted you guys to guess before I clicked it. 1 plus rate over compounding period is to the power compounding period times the number of years and
Plus, you put a plus.
oh,
Okay.
shit. Times. Whoa!
Oh, it is.
It didn't take twice as long. It took the same amount of time. So Greg was saying it was pretty damn close to 13.9. Yeah. Check it out. Let's put 1,000 back in there. How about 100? It's weird. Why doesn't it matter the investment amount? Doesn't it seem that way? The investment amount doesn't seem to matter. It takes the same amount of time to double, even if I put $1 in there. Or $1 million. Oh, I get a little extra there. But that's because I have more places to look at.
There's a fixed rate that money's
Yeah, but it's the rate that matters, not the amount you invest. And so if you think about it here, basically, like thinking back to algebra, I'm trying to solve this equation, right? And it really doesn't matter whether I started with $100 or $1,000. For example, if I started with $100, then I'd be wanting to get 200 there, right? But if I was going to solve this equation, wouldn't I divide both sides by this value, whatever it was there, to get it out of the way? And then look at what's left. What's left is on this side there's a 2. On this side, there's everything else. The parentheses 1 plus 0.05 over 12 to the power of 12t. T is the number of years. So it turns out it doesn't matter what you invest. What matters is you're trying to double. And it takes the same amount of time to double as long as you stick with 5% compounded monthly. That's all that matters. Doubling time is fixed from there on in. Because when we try to solve any equation, the original amount divides out, always leading to a 2. Why a 2? Because we were trying to double.
So when you buy a house and they say you're on a fixed rate,
Yes.
you want the fixed rate?
You do want the fixed rate. Because the variable rate usually means it's like they're trying to sucker you in. We'll give you 5% for 5 years, then we're upping it to 10%. Then all of a sudden you can't afford your payments anymore.
Got it.
Yeah. So that's dangerous. So that's what I wanted to take a look at next. I want to look at how a mortgage calculation works with arithmetic. The formula for a mortgage calculation makes this thing look like first grade math. It's a lot more complicated. It's not really bad, but it's significantly more complicated. That's what I was trying to put on the board the other day, and then I got lost. And I'm not ready for this. So here's what we're going to do on the spreadsheet in the other room. I don't know, just stop this recording in a minute. Oh, here's another trick, by the way, on the spreadsheet. Rather than just typing numbers here and watching this change, what I could do is just move this over to give myself a little room to calculate. And I could put a years column here. And then I just start typing some years, like 6, 7, 8, and so on. And I could fill that down. Remember the magic fill button? And then I could take this formula and fill it down. Now maybe I'll put my $1,000 back there. Make that look pretty. One problem though is when I try to fill that formula down, it's gonna, when I copy this down, that A2 is gonna change to an A3, and the B2 is gonna change to a B3, and so on. I showed a trick to do this last quarter. Does anyone remember the trick to tell it not to mess with the A or the 2 or the 2 here? The trick is to use a dollar sign in front of it. Because right now, watch what happens when I copy this down 1. It says division by 0. The reason is, it changed all of my row 2 references to row 3 references. Why? Because I copied it down 1 row. So the way to fix that is if the balance is always in this row and the rate is always in this row, in your formula, put a dollar sign in front of the row number. And then it says, don't mess with the row number. Don't touch it. If I was copying this left or right, I would put the dollar sign in front of the letter. Those are called absolute cell references. Now if I fill it down, it'll always look in row 2. It won't mess with it. It sees the dollar sign and says, ooh, don't touch, don't touch, don't touch. But if I were to try and copy this to the left, all hell's going to break loose because it shifted all those references one column over. Okay. So that's an important use of spreadsheets. So now I could just fill this down. Oh, I want to fix it so the years, where's the year? Orange, red. Instead of grabbing the year from there, I want to grab the year from here. And that one I do want to change each row, so I'm not going to put a dollar sign there. So I can see what's going to happen after each amount of years. And so I can see it watch my money grow each year. And eventually I can see, oh, look, it doubles somewhere between 13 and 14 years. And then if I kept filling it down, I could see where it's going to double again.
It's a long time until your investment.
Yeah. Sometimes it takes time for everything to grow. So let's see, where's it going to double again?
Nope.
Shit. To get numbers to increase, you have to have a pattern of 2. So I should see at 28, it should just about double again. From 1,000, 2,000, 2,000, 4,000. So every 14 years, I should see my money double from whatever it was. So that's not bad. I made $1,000 over the first 14 years. Over the next 14 years, I made $2,000. Takes money away.
Then that $2,000 in 14 years is worth about $100.
Okay, so yeah, then we have to deal with inflation. Now, inflation usually isn't 5%. It's usually around 2%, 1.5 to 2%. Sometimes 3 in really bad times. Okay, so here's what we're going to try to do next. What we're going to do is analyze how kind of mortgage payments work, or how an investment grows if you put $100 in the bank each month. So suppose you're like putting away for college savings. to do that, we need to keep track of the month that we're in, the payment that we're making, the interest that we collect, interest. What else do we need? Payment, interest, and then a new balance. That's it. So let's say in month 1, we pay $100. And let's say we made the payment at the beginning of the month, and so that at the end of the month, we're going to collect some interest. Now, we should put our rate in here somewhere. What rate do you want to use? 2%. Okay, so that's going to be really slow growing. And so as far as the interest goes, that's the simple interest. It's our payment times our interest rate times time, which is 1/12 of a year. And so in this case, I guess I should dollars. In this case, then my balance is just going to be equal to my payments plus my interest amount. So I got $117 for the first month. Now, month 2 comes along, and I'm going to make another payment of $100. Now, here's where things get a little more complicated. And this is what we hit the other day in class, but the computer can do it easier for us. When we calculate our interest, our balance is now this and that, because we just put $100 in.
We balance plus payment.
Yeah, so what I'm going to have to do is put parentheses, take my old balance, and add my new payment to that. And both of those are going to collect interest for 1 month. And so my new balance is now equal to my old balance plus my payments and interest. It's going to start getting easier on the next line, so let's do the third line. Third line, how much am I paying?
100.
Let's take $100. Now I could just fill it down from above, right? So I could just take this 100 and say fill it down, please. Over here, let's see, how am I going to do the interest again? Equals. Well, isn't it my previous balance plus my new payment? And then I'm going to multiply that by my rate, and then multiply that by my time. Isn't really that the same exact thing that I did up here?
Mhm.
Yeah, they're the same formula. The only difference is the rate is always in the same spot. So if I wanted to fill this formula down, then I'd want to say, don't mess with row 2 for the rate. It's always in row 2. But the balance changes each month, so that doesn't get a dollar sign. So let's test it out. If I fill that down, I should get the same 50 cents. I'm good. My formula is fine. How do we calculate the balance?
The old balance.
Old balance
the
plus
new balance,
plus
the payment.
plus the interest. Yeah. Now, really, isn't that the same thing I typed up here? Previous balance plus new payment plus new interest. Now, there's no dollar signs there. So to get that 301, I should be able to just take this one and use the magic fill button and drag it down once, and it works. So now I think I have formulas that I can just fill down, and they should keep generating my new amount. So I'll just do it a little bit and see. So I should see my interest growing each month. It's growing each month. If I double click on one of them like this one, it says take the previous balance plus the payment and give me 12% interest for 1 month. That seems to work. Double check how the balance is calculated. Previous balance plus new payment plus interest. That seems to work. So if you were putting $100 away for like a college savings plan or some kind of retirement plan, this is exactly how the math would work if somebody was giving you 2%. Now there's a fancy formula that will calculate any particular month for us automatically, but we can just use simple arithmetic to do each line. And then I can just fill this down as far as I want. So let's put a 4 here. To make the 3-4 pattern go, I need 2 rows, and then I can just fill it down and see what happens to it. So let's see, if I went 120 months, oh shit. 120 months would be 10 years, right? So we can see what this looks like in 10 years. Okay. So if I can color it more. So $100 a month, I get $13,000. And we got this extra one. How much is $120 a month worth on its own? Well, 100 times 120, right? That would be $1,200. Is that right? $12,000, right? Only 2 zeros. $12,000. So how much interest did we make at 2%? It's like 1,300-ish. Double check by going equals and oops. Double check by using that auto sum button. Excel has the same button. Sum all of the interest amounts. So you can see the relationship between this and this here.
$1,000 a year.
So we made $1,000. 2% isn't much, you know. So I made $1,000 over 10 years. But I could easily tweak the way I set this up. Let's cut them out of there and put them at the top. Stick them off to the side here. So this is interest. Some payments. I could make it 5% and see if there's much of a difference. 5%, I make $3,500, almost $3,600. Maybe I find a really great investment at like 8%. I'd make $6,000. Half my money over.
Today, everybody has interest rates, the highest one I can find.
Yeah, interest rates right now suck. So yeah, 2% would be like fantastic interest rate. So, and that's paying $100 a month. That's totally different than putting $12,000 in the bank now and seeing what it's worth. That's our other interest form that we were calculating earlier. What would that be worth in 10 years? And we could double check that on our other sheet.
I thought it would manage accounting all of a sudden.
Yeah, well, I mean, this, you're gonna do interest stuff and we just need to see where it goes. So we have the, oops. Yeah, so I'll go over this with you in the other room in just a second.
Okay.
So just to check that, if we invested $12,000, 1, 2, 3, at 2%, then in 10 years we would have $14,000. Okay, so we would make $2,600. Whereas if we pay $100 a month to accumulate $12,000, we make $1,300. Okay. You make twice as much interest roughly if you have $12,000 to invest now. I don't, but maybe I can do $100 a month over 10 years. I love it. Okay. So what the goal is here is we are going to go to the other room and we're going to try and reproduce this spreadsheet right here. And this spreadsheet right here is a lot like the spreadsheet for a credit card balance, but instead of adding stuff up, it's take away. But it's the same exact math. We could make this one step easier in terms of all the different things we're adding up here by having an extra column called payment plus interest. It's easier just to do it this way. So we're going to try and reproduce in this and the other room. So we're going to do a month, a payment, an interest, and a balance. I like typing the rate here because then I can change it and explore. We could just type the rate in the interest formula here, and then we don't have to worry about absolute cell references, which that messes with people sometimes. All right, so let's go do that, and then we'll come back in here and play with a couple other ideas.
Leave our stuff in here.
Yeah, just leave your stuff in here. We'll come back. If you have your own computer, you can take that with you. If you don't have a computer, we're going to log in and put a computer in there. Stop this.